Okay, alright. This is part for the part one for DC analysis of common emitter amplifier. This circuit I construct from the lab sheet. I follow all the picture from the figure 4, and then as we see that I use a resistor. Is a 10 kilo ohm, and this is a 1.2 kilo ohm. This is a 68 ohm. This is a 680 ohm, and I use three capacitor, which have reached the same value, which is equal to C1, C2, and the C which is all the value is 470 microfarad. And I use this transistor. The name of the model is 2N3904. Alright. Following the figure in lab sheet, this is a VCC, which is a 50 volt. So I run the simulation. Right, can I pause? Okay, before I forgot to say that this is a VCC, this is a value for the IC, this is the IB, this one is for the VB value, this is for VBE value, this is for the IE value, and this is for the VCE value, and also this one for VE value, and this is for the VC value. Alright, following the table that I can be recorded and put in the lab sheet. This is for the IC, which is I got a 33.8 milliampere. This one is 0.2 milliampere for IB. This is for the VBE value, and I got a 0.79 volt. And this is for the VB value. And we got a 3.1 volt. Okay, next, which is this is VCE. The value was a 5.01 volt. Okay, and this one is for the value IE, which is we got a 34.0 milliampere, and this is for the VE value, which is we got a 8.2 volt, and this is for also for VC, and the value is 8.2 volt. Okay, this is for the part 2, which is this is for the AC analysis of a common emitter amplifier. Following the lab sheet, that I need to modify the circuit before, and this is the circuit that I already modified. That I used to apply a small 30 volt peak to peak. Sinusoidal input at 5 kHz using a signal generator, and connect the oscilloscope to the circuit to observe the input, which Vs, and the output signal is a VO. And I need to make a sketch of this voltage and calculate the voltage gain AV. So I already add something in this circuit, which is this is a resistor with the value 3.9 kilo ohm, and I use this for signal generator. Okay, for this signal generator, okay, I always use the amplitude, which is equal to 50 milli, which is we use the half from the photon peak to peak, and the frequency that already state is 5 kilohertz. So okay, and okay, next and we connection the signal generator to the oscilloscope, which is in the signal A, and that will be for the V voltage Vs, the input voltage, the signal. And for the at B, I connect to the last one resistor, which is this is for the VO. Okay, and then before that I debug first and reset debug pop-up window, and yes. After that I run the simulation. Okay, as we can see here. Okay, we just use a channel A and channel B. So for channel C, we just off that, so we don't use that. Okay, so we change the waveform first for the channel A. Okay, this one I'm gonna change it first. So that will be for 10 millivolt. Okay, for the channel B, which is to go to 1 volt. Okay, and then this one will go to the 0 position. Okay, so 0 position will just the state into the middle of the line. And next we go to the horizontal, and this one I'm gonna change to the 50, which is I smallest their wave. It is gonna state for the 200. And then this is the first waveform for the first second. Is the oscilloscope at the axis, increase the input signal amplitude, which is Vs, until clipping is observed, and then reduce the input until the maximum output voltage that contains no signal of the clipping is found, and record the peak-to-peak value of both of the input and output voltage. So that means that you want to change this one, which is the amplitude for the Vs. Just stop the simulation. Okay, go to this one and change this amplitude, which is we want to go to the maximum output. And so we got a 50 mil, so they want a maximum, so you need to increase the amplitude value. So I choose for the 13, so there is a 13 milli, and then okay. Okay, so we do it again. So reset debug pop-up window, and a yes. So and then I run. Okay, so this is the value that come out from that already changed. So I stop. Okay, I change this the pause. Okay, so this is for the this one for we need to change the signal amplitude, which is he want the maximum value, so I go to the 33 because the value is not really good, so I change this for 33. Okay, and I debug again. Reset debug pop-up window, and yes, and run the simulation. So this is what we got. Okay, and this is the graph. This is the waveform that answer for the second part. Okay, I will close this waveform and stop the simulation. Okay, so next question, which is I need to set a VS is 30 milliV for photon P2P and remove the 470 micro farad bypass capacitor, which is for the CE. It is one, and measure the output waveform. So we want to remove for this one. So I'm gonna remove it first. Okay. Okay, we're done. So I debug again, and I run the simulation. Okay, so and this is okay, and this is the waveform for the last question.